This is the beginning of Chapter 8, and this has to do with polar coordinates. Polar graphs is in here. We're going to skip over that, but then we're also going to talk about the polar form of a complex number and vectors, directional vectors. So those of you who are in physics, actually, this stuff might be kind of a breeze for you. Hopefully, of course. Let me get this out of the way. So the polar coordinate system uses distances and directions to specify a location from a point on plane. So we have a fixed point O, which is normally our origin. Okay, that's normally how we draw from the unit circle anyways. Then we draw a ray from it, which is called the polar axis. So if you look below, there, that black line is your polar axis. Each point P can be assigned a polar coordinate. So that it's somewhere where there's a theta, like an angle, and then it has an actual value. The r is the actual distance of how long you draw that segment, and then theta, which is the second piece, like a y value, so to speak, is the actual theta that you use to go that many degrees. Same thing like when we did trig functions. To go in a positive theta, you have to go counterclockwise. So here's our positive theta and then our r value drawn. This would be, this one down here is actually would be in a negative direction. This would be like if we went this much theta and then drew it negatively. Okay, if that makes sense, if the r was negative. All right, so we're going to mock draw these. So I have my polar axis, roughly, pretend it's a straight line. And instead of going pi over 6 is 30 degrees. So I'm going to go up 30 degrees and draw a dot. I'll label it P. This is 1. This is pi over 6. There you go. There's your polar coordinate. So 1/2 5 pi over 6. 5 pi over 6 is 150 degrees. So I'm going to draw this. Here's my polar axis. 150 degrees. You go, there's like 290. There's about 150, roughly. We'll say this is a half. Label it so I know, or whoever's grading knows. That is what you're talking about the length being. And the last one, -4, and then 101 pi over 2. 101 pi over 2 is 270 degrees. So, but it's like wrapped around a bunch of times. But that would be the reference angle. So from my polar axis, okay, I would go around, so it's over at 270. Okay, I drew it dotted because it's a -4, which means I have to go in the back direction. So this is actually -4. The value is 4 because it is a distance, and you can't have negative distances. But it goes backwards because it's negative. The coordinates r theta and -r theta plus pi represent the same exact point. So if I have, well, I'll do it with this next example, which actually is, yeah, I could do it with this next example, that's fine. So 2 pi over 3 is 60. 2 times 60 is 120. So this is really 120. So if we were to draw it, though, we'll draw these, and then I'll do the rectangular coordinates. So 120 is actually like up here. So this would be 3. This is like 120 degrees. So what that statement is saying before, that if we do -3, and we do 120 plus pi, which is 180, these two should essentially be the same actual like picture. Well, if I could draw that. Here's my polar axis. Okay, so 300 is actually all the way down here, where this would be like our 270. So 300 is this way. I would normally draw a vector this way, but because it's a -3, I'm going in the backwards direction, which means I go back that way. That's 3. This is our 300. And look, it's the same exact picture. That's what that statement's saying, that you could replace those things and still get the same exact picture. Now, rectangular coordinates actually have to do with this down here, how to figure them out. I don't know if this is, make sure that this is actually written on your paper. It's y over x. I don't know if it was cut off or not. But you need these pieces. Find the x and the y. Well, our r is 3. Our theta is 2 pi over 3. We just got to plug it in. So to find the x value, we get 3 cosine 120. To find the y value, 3 sine 120. Okay, remember this is 120. If you didn't remember, it's right up there too. Cosine of 120 is a half, because we're talking about reference angle of 60. Cosine of 60 is a half, but in quad 2, it is negative. So 3 times negative half is negative 1.5. Sine of 120 is radical 3 over 2. So 3 times radical 3 over 2 equals 3 radical 3 over 2. And there's your point, xy. Negative 1.5 is the x. 3 radical 3 over 2 is the y. Okay, so there's polar graphs, which is the r and the theta. Then there's our rectangular coordinates, which is a regular grid, like a regular coordinate grid, which is our xy's. Okay, so those are the two pieces you need to know to figure it out. So find the rectangular coordinates for those polar coordinates. We're going to do it again. Our r value is negative 4. Theta, 5 pi over 2. 5 pi over 2 is 450 in degrees. Because 90 times 5, 450. You good so far? I hope so. So x will be our r, negative 4, times cosine of 450. Our y is negative 4 sine of 450. Well, cosine of 450, the reference angle is 360, so 90. The reference angle is 90. Cosine of 90 is 0, so this is equal to 0. Sine of 90 is equal to 1. So this is negative 4 times 1, negative 4. I'll write this in. 4 times 0 is 0, negative 4. So our point is 0, negative 4. Which actually, if you draw those two, you get the same thing. If you would actually draw, because 0, negative 4 is down here. And if we know that this is 450, so we go around, go around to get to 360. And then up to 90, but since it's negative, we're going to go down. Same picture. Finding two polar coordinates from rectangular coordinates. Well, there's other pieces that we need. We need to know that r is equal to x squared plus y squared. Kind of like Pythagorean theorem. So to find r, negative 7 squared plus negative 7 squared, 49 and 49, which is 98. And then if we simplify this, r is equal to 7 square root 2. And the other piece from the front is that tan theta is equal to y over x. So negative 7, in this case they're the same, so negative 7 over 7. So what is tan 1? Tan is 1 at 45, right? But this is a reference angle, because if you look at a graph, negative 7, you are in quad 3. So we need to make this theta quad 3, which is 225. I'm running out of room. Let me erase this picture. Okay, so 1 point, because it says find 2. 1 would be 7 radical 2, and then 225. I'm pretty sure we're supposed to have these in radians, just so you know. So this is 5 pi over 4. I think they're supposed to be in radians. And the other would be the negative version of r, so negative 7 radical 2, and then add 180 to that. 180, or pi added to 5 pi over 4 becomes 9 pi over 4. Those are the two values. That's a pi. Converting equations. Well, x equals 1. Well, x is equal to r cosine theta, right? That's from the formulas up from up front. So that equals 1. Well, I just need to get r by itself. So as r is equal to 1 over cosine theta, well, 1 over cosine theta is secant. So r is equal to secant theta. And if you have x squared equals 4y, we'll replace x squared with r cosine theta. So that's being squared. Replace y with r sine theta. I go so far. So I'm going to square the left side. So r squared cosine squared theta for r sine theta. Well, one of my r's on each side can go away, right? So I will divide cosine squared theta over to the right. And I can separate, so if there's 2 cosines, so it's 1 over cosine and a sine over cosine, because sine over cosine is tan, 1 over cosine is secant. I can just make it look prettier instead of what was there. It says going from rectangular to polar is easy because we could just replace the x and the y with r cosine theta and r sine theta and then simplify. Going this way is not so much easy because you kind of have to like visualize it. This is like going kind of what we already did. Change secant to cosine because none of the polar functions have a secant in it. They either have a sine or a cosine. That's what you want to get your equations to. So if I multiply cosine over, I get r cosine theta equals 4. Well, r cosine theta is equal to x. So x is 4. There's our equation. If we have r equals 4 sine theta, this is weird because there's not much you can do with that, but we can multiply both sides by an r. That'll give us something, because then we'll have r squared equals 4 r sine theta. Well, this piece is x squared plus y squared. And this piece is equal to y. Well, that's a little bit better. So x squared plus y squared minus 4y equals 0. Starts to look like an equation of a circle. So we're going to rationalize, or not rationalize. Oh, do that thing to make it circles. Whatever that thing's called. You know, negative b divided by 2 squared thingy. So y squared minus 4y. Add 4 there. If I add 4 there, add 4 on the other side. I need more room. What is that thing called? It'll come to me probably after I record like another 2 sections. So then that changes to y minus 2 squared. And it is a circle. And the last one, we have r equals 5 plus 4 cosine theta, which there's not much I could do with this, but I can multiply everything by an r again. So r squared, 5r plus 4r cosine theta. multiply r times everything. R squared is equal to x squared plus y squared. Then we have 5r plus 4x, because r cosine theta is equal to x. So I'm going to move my x term over. So minus 4x plus y squared equals 5r. I need to get rid of that r. Well, the only way to change it is to multiply everything or square it. We could square it instead of multiplying it by an r. We could square it. Ooh, this is going to get funky. But I'm not going to actually do anything. I'm going to leave the left side the way it is because it's going to get absolutely ridiculous if I actually try to FOIL that out. And this side is 25 r squared. And r squared is equal to x squared plus y squared. So left side, that's a minus. X squared minus 4x plus y squared, all squared. 25 x squared plus y squared. Replace the r squared with the x squared plus y squared. And that's what we're going to get. That's just going to be too ugly for us to actually record. And that is the end of the first section.